Hi, welcome to Apex Fluid Power. Chances are you've seen a hydraulic hose failure like this before. This video will show you how to make a new hydraulic hose from scratch. To begin with, you will need to select the correct hose to replace the old one. This can be done by referring to the manufacturer's specifications or using the hose ley line. Ley lines are the text printed or moulded onto the hose, often featuring part numbers, size, standards and working pressures required to make hose selection simple. From here, we need to identify the required fittings. Many machines use common types that you will be familiar with, but it is easy to get mixed up. As a basic guide, BSP shown here features a 60-degree cone sealing face, and with the male having an inverted cone. JIC or JIC fittings have a 37-degree cone and seal metal to metal, with the male having a convex cone. ORFS or O-ring face seal have a flat sealing face, with the male housing an O-ring. Metric fittings, common throughout Europe, seal on a 24-degree cone. Flanges, often used on higher pressure lines, can be code 61 or 62 depending on pressure. More information on thread forms and identification can be found on our website. Once we have our hose and fittings, we must measure and cut the hose. To accurately measure the original assembly, it is industry standard to measure cone to cone to ensure the correct cut-off length. On straight fittings, this is the sealing point inside the nut. On 90-degree fittings, you measure up to the centre line of the sealing face, which is the same shown here on a 45-degree fitting. Once we have measured the original hose, we must note the cut-off length of the selected fittings to determine the cut hose length. This is the point from the sealing face or centre line of the fitting to the full hose insertion. This is important as different manufacturers have different dimensions, such as long and short elbows. For example, the original hose is 1310mm. Taking off both the cut-off lengths of the fittings gives us a cut hose length of 1240mm. Once the hose is marked, we cut it using a dedicated hose cutting machine. The die pins shown here are important as they open the hose onto the blade, ensuring the blade life is longer and provides a cleaner, square cut. The pins have location points for small and large bore hoses. Using a cutting machine provides a square cut necessary to ensure a perfect seal when swaging the fittings. This is aided by a serrated disc blade cutting efficiently and smoothly through the hose. A common tool often used is bolt cutters or chop saws, which give a rough, distorted cut. Shown here with an ideal straight cut, we can push the fitting onto the hose, ensuring the collar bottoms out on the square edge. If we had used the cut earlier with the chop saw or cutters, the fitting will bottom out early, causing a leak when the hose is fitted. This will obviously be exaggerated on larger bore hoses such as multi-spiral lines. When inserting two piece fittings, it is important to line the collar with the trap inside the ferrule. Quite often, the ferrule is pushed on too far and the collar does not locate in the trap, meaning a seal will not form. Always keep a close eye on this. As for one-piece fittings, we need to make sure the hose is pushed on all the way. This is done by marking the point where the ferrule will push to, known as the insertion depth. This makes it easy to tell the fitting is fully inserted. Finally, if we need to set the angle on the assembly before swaging, this is done very simply. The end furthest away is set pointing upwards, or 0 degrees. and we rotate the closest end to the necessary angle, such as 90 degrees or 180 degrees. Now we have our hose assembled, we need to swage it. First, we find the correct swage dimensions, which should be provided by your supplier. All swaging machines are different and setting up varies. Commonly, on pallet swage machines, once you know the swage dimension required, you will select the nearest die set without going over your required final swage. This is because, when the dies are close together, the hole in the middle measures what the die says, in this case 38mm. Then, when we adjust the vernier dial, each full revolution increases the final swage by 1mm, here to 39mm. 2 revolutions gives us 40mm. This is shown when the dies are close together, they will not close completely, as they now measure 40mm, 2mm larger than before. When swaging the hose, make sure the ferrule is set back in the head to swage the full ferrule and allow for any expansion. Then, simply check to ensure a correct swage. This can be done with a vernier micrometer or no-go mandrels. Here is an animation of a correctly swaged hose, allowing unrestricted flow of oil. If the hose is undercrimped, then the compression seal is not formed by the hose tail and the ferrule. This allows leak paths to form behind the hose tail, and oil is forced through the wires of the hose and can cause blistering, leading to hose bursts. The alternative is overcrimping the hose, which compresses the ferrule and distorts the hose tail. This can reduce the flow rate, as well as being exaggerated on large bore hoses. It can cause blockages on small bore hoses. There are many types of swaging machine, all with different operations and setting up. For example, the Parker Carry Crimp features colour-coded die sets for each hose size. The die sets also have a self-aligning collar, where the fitting rests for accurate swaging every time. These machines don't need a vernier, as the die sets are linked to each hose size and type. Finally, hoses can be cleaned to varying degrees of NAS cleanliness, as this eliminates any residue from cutting and swaging the hose. They should also be plugged and capped to seal the ends until they are to be fitted. At Apex Fluid Power, we manufacture hose kits and assemblies for a huge range of applications and can supply fully tagged, labelled and tested hoses and kits to meet any requirement. For more information on any hose, fittings, machinery or any of our other products, go online to apexfluid.co.uk or give us a call on 01228 511 157.